So here let's say you're very rich and you have a plane, and well, you wanted to turn, you have like a yo-yo, but you wanted to turn the acceleration that your plane has because you're a millionaire and you have nothing to do exactly at that point. So let's say this is you, you're one in your hand, this is you, and your yo-yo is doing like something like this, and it makes an angle of 22 degrees with the vertical. So this would be like pretty much this thing. Okay, so from here we can tell we have enough data for us to just like get everything done and check things. Okay, so first of all we need to do our free body diagram. So remember we have to draw some nice axes from for us to work, and remember that everything should be done at the center of the mass of our object. Okay, so it should be done here, right here. Okay, so everything should be done here. Okay, so the mass is going down, so there we have weight, and we have this stuff just like going around here, and this tension. Okay, we know that the angle is 22 degrees respect of the horizontal of the vertical things, so angle is gonna be here. Okay, this is gonna be 22 degrees. Okay, so let's settle our equations to everything. Well, let's do the symmetry of the forces in X, and I'm just gonna have, well, I see my diagram, and I say, okay, dude, well, the only thing that's going on there is just like the tension, and I need to check what reflects to it, so I know the angle. Let me change colors because it's gonna be a little bit confusing. This is the angle, okay? So I need to check which part of this line goes directly into the x-axis. That's gonna be this one over here that I'm checking in green. Okay, so well, you say, dude, okay, if I use the cosine, cosine is gonna go directly into the y-axis, so that's no use for me. But so this time I need to use the sine. Okay, so thing is, the rule that always cosines go with the x-axis doesn't happen anymore all the time, so we need to be very careful of it. Okay, so let me go back to blue, and there we go. No, there's the other blue, this one. So t is gonna be sine of theta, and well, you know that the airplane is moving, so you have like mass times acceleration. Okay, now we have also the equation for the y-axis. And it's gonna be upwards. You have also only just like the tension. You got instantly, if you want sine in the other one, you automatically got the other one on the other thing, so it's gonna be cosine, and the weight's going down, and it's not moving on the y-axis. Okay, so from here we need to know the mass, we need to know the tension and the acceleration of this guy. So well, let's say that it's easier to get the tension first, and that would come from the second equation, the one in F. Okay, this one F. Okay, so T cosine of theta is going to be equal to the weight. So the tension is going to be weight over the cosine of 22. There's going to be weight, it's going to be mass, that's 40 grams. That's 0.40 times 9.81 over the cosine of 22, sorry. And this is going to be equal to 0.423 newtons. Okay, so there we go. This is part B. For part A, you need to know the acceleration. We can get it easily from the first one. So because we know that tension sine of theta, that's going to be equal to 4 times acceleration. So from there we solve for the acceleration. That's going to be t sine of theta over the mass. And well, we just found the tension. That's 0.4023 times sine of 22 over 0.04, and that is 3.96 meters over second squared. Okay, so this is our result. Don't forget the units. And that's all.